Okay, so today we're going to start with solving linear one variable inequalities. So in order to talk about inequalities, we need to discuss first our symbols. Okay, so you're staring at some four symbols right here. And this symbol, we always read it kind of left to right. So this one is the less than symbol. So less than. The second that we have a little line underneath, either here or here, okay? You can think of it also as part of an equal sign. So this would be less than or equal to. Okay, this one would be greater than, and then this one is your greater than or equal to. The best way to kind of remember the difference between them is for less than, if you think about your symbol, it kind of looks like an L. So the L kind of represents the less than symbol, okay? We usually have a variable and then we have a number. And so one example that we can see is kind of comparing the solutions to this, right? So the difference between an inequality and an equation. When we have an equation, we're solving for usually one variable. So in an example like this, there is only one solution. Okay, and that means in this equation, when we plug in the number 3, that's the only thing that's going to work. 3 is going to equal 3. 2 can't equal 3. Negative 3 can't equal 3. But for this, right, when we see x is greater than or equal to negative 2, this is multiple solutions. Okay, this means that I can plug in any number and I can see if it is a true equation. For example, negative 2 might not be greater than itself, but it definitely is equal to itself. So that's a true statement, all right? What's another number that's greater than negative 2? You could say 0. 0 is definitely greater than negative 2. Right? What else is greater than negative 2? Let's think big. How about 1,027? Right? That is definitely greater than or equal to negative 2. Now, obviously, it's not equal to it, but it is greater than. So we know that we have multiple solutions. That's really the main difference between an inequality and an equation. An equation is going to be one solution and that's it. And an inequality is going to be multiple solutions. So how do we go about and solve for one variable inequality? So let's take a look at this. There's two things that we're going to do. We're first going to solve the inequality, and then we're going to graph it on a number line to represent the different types of solutions we have. So treat the inequality just like you would an equal sign, right? So the first thing I'm going to do is I'm going to add 5 to both sides. So I'm going to get 2x is greater than or equal to 8. And then I'm going to divide by 2, and I'm going to get x is greater than or equal to 4. So that is my inequality statement. So any number that is going to be greater than or equal to the number 4, I can put into this inequality statement, and it will be a true statement. So how do I represent that on a number line? Okay, so the first thing I'm going to do is I'm going to draw just a quick number line. Okay, and you don't need a lot of numbers on your number line. The main number you need is the number that you found, so 4. So I'm going to put that kind of in the middle. And I'm going to put a number to the right and a number to the left. So that way I know the direction that I'm going. So 5 and then 3. Okay, now 4 is our starting off point. So 4 can be equal to itself. So how do I represent that? I'm going to represent that with a closed circle right above the number 4. Some people put it on the number line. I prefer to put it just above the number line. Okay, and what's a number that's greater than 4? If I am just given these two numbers, 5. 5 is definitely greater than the number 4. So that means that my solutions are going to be going bigger than the number 4. So I can plug in 5, 6, 7, 8, 9, 10, a million, all that stuff. So how can I double check that that 5, 6, 7, 8 will work? Because I want to make sure that it checks out. I'm going to go ahead. I'm going to plug in 5 into my inequality, and I'm going to see what happens. So here's my quick little check. So I'm going to say 2 times 5 minus 5 is greater than or equal to 3. So 5 times 2 is 10. And 10 minus 5 is 5. And 5 is definitely bigger than 3. So I know that I solved everything correctly. I know that my arrow is pointing in the right direction. So I'm going to go ahead and box my answers. Okay? So, what happens if we have an inequality that kind of looks like this? Okay, so I'm going to solve it in 2 ways. The first thing I'm going to do is I'm going to actually move the 2x over to the other side because I want to keep that positive. So I'm going to say 3 is greater than 1 plus 2x. Now I'll subtract the 1 to both sides, so I'm going to get 2 is greater than, or sorry, less than, my apologies. So 2 is less than 2x. Divide both sides by 2, I get 1 is less than x. Now I can rewrite this, so notice that the inequality sign is opening up towards my x. So I can rewrite this as x is actually greater than the number 1. Okay, notice that there's no line underneath, which means that 1 is not included in my answer because 1 cannot be greater than itself. It can be equal to itself, but it cannot be greater than itself. Okay, so this is one way that we can solve it. Okay, now the second way. Put a little line over here. Now what happens if you didn't move this 2x over onto the other side? Right? You move the 3 over to the other side. So I'm going to go ahead and do that. And I'm going to say negative 2x is less than minus negative 2. Now, over here, we are about to divide by a negative 2. Okay? And when you divide by a negative number, your inequality sign flips. Okay? Because notice that we have to get it to be a greater than symbol, and right now it's a less than symbol. So that would be your flip. Okay, like I said, you don't have to ever divide by a negative number because you can always move your variable to the other side. But when dividing by a negative number, okay, you must flip your inequality sign. So now notice that we got the same answer twice. Obviously, I want to check that this is correct. So here's my quick check. What's a number larger than the number 1? Let's try 2. Right, so 3 minus 2 times 2, less than 1. So 2 times 2 is 4, so 3 minus 4 is less than 1, and definitely negative 1 is less than 1. So if we had done it in this fashion over here, and you gotten a number that was, say, x was less than 1, we would have tried 0, right? And we plug that in. 3 minus 0 would have given you 3. 3 is definitely not less than 1. So we know that we had made a mistake. So my recommendation whenever you're solving these inequalities is just to double check your answer. So I'm going to go ahead and I'm going to box x is greater than 1. And how am I going to draw that? Quick little number line. Put my 1 in the middle, right? Number that I've already tried is 2. Number I didn't try technically is 0. Now 1 is not included because 1 cannot be less than itself. So we're going to have an open circle, and again we're going to point in the direction that we checked. So we check the number 2, and we draw with an arrow. As long as you have an arrow pointing in that direction, you don't have to make your line go as far. So notice on this one I made my line kind of go further. On this one I did not. Okay. What happens if we get a little harder, right? So 9k minus 4 plus 1 is less than or equal to 2k minus 3 plus 7k. So let's go ahead and combine your like terms. So we have 9k minus 3 less than or equal to 9k minus 3. Well, notice that we have exactly the same thing on both sides of the equation. So if I subtract the 9k to both sides, I get a -3. It's less than -3. Now, something cannot be less than itself, but notice that there's a line underneath, which means that -3 can be equal to -3, which is a true statement. So this is a true statement. Okay, and if we remember back to solving equations when our variables canceled out and we're left with a true statement, we are given a solution as all real numbers. Okay, now technically we can graph this, all real numbers. It's the easiest graph that you're ever going to see. Just draw a quick little number line, put a 0, put a 1, put a -1, doesn't matter what you have there. And you want to include all real numbers. So that means I can include -infinity all the way to positive infinity. So I can just draw a line right on top. Okay, this one's not as important to draw an inequality, to draw the inequality number line. Okay, if we want to write these also using your, what's the word I'm looking for? Set notation, right? If it's a true statement, which means it's all real numbers, if you think back, this would be -infinity all the way to positive infinity, okay? Which means if we actually go back to the first two problems that we had done, right? The first one said x is greater than or equal to the number 4. How I could have written that in set notation is a bracket, right? 4, comma, all the way to infinity, right? So this means exactly the same thing as that, which means exactly the same thing as that, right? Obviously, greater than, no line underneath, that would be a parentheses. So this would be parentheses 1, comma, infinity. Remember, smallest number all the way to the largest number. So set notation. All right, so let's do one more. So we saw in all solutions. So here we're going to see a no solution. So 3y plus 1 is less than 3y plus 1. So if I subtract the 3y to both sides, I have 1 is less than 1. Okay, this is not a true statement. 1 cannot be less than itself. So false statement, which means no solution. Again, we don't necessarily need to graph a no solution. If we wanted to, you're literally graphing a number line with nothing on top, right? So we don't see an open circle. We don't see the line across like we did here. And for no solutions, there is no set notation because that means there are no numbers I can be able to plug in for y in order to get a true statement. Okay. So the last question that I'm going to leave you with is a word problem. You might want to pause it as we copy this down, right? Zoom out a little bit. So an inequality word problem. In 1912, Japan gave the U.S. several flowering cherry trees as a symbol of friendship. Japan plants cherry trees when they are 6 centimeters tall, and they grow 9 centimeters each year. The trees start to flower when they are taller than 150 centimeters. It was important that the trees flower this year. How old must the trees be? Okay, so again, we're assuming that it's still 1912, not current year. Okay, so this would definitely be an inequality statement because it needs to be taller than 150. So they can give something that's 151 centimeters, 152 centimeters, 160 centimeters. So this would be an inequality statement. So the first thing I want to do is I want to write a let statement. I'm going to say let x equal the age of the tree, of cherry tree. Okay, so I'm going to write an inequality statement. So I know that they are 6 centimeters when they're planted. So this will be 6. And they grow 9 centimeters each year. So that means after the first year of planting, it'll be 9 times x. After the second year, 9 times 2 plus 6. And I know that it must be taller than 150. I don't want it to be equal to 150. So I'm not going to put an equal sign underneath my greater than symbol. So I'm just going to leave it like that. 6 plus 9x is greater than 150. I'm going to go ahead and solve for that. So 9x is greater than 144. And then if you do long division, divide both sides by 9, you are going to get x is greater than 16. So now I know that the trees must be older than 16 years. So how much should the trees be? Older than 16 years. So it can be 16 years in one day or 17 years and stuff like that. All right. But on a side note, the trees stop flowering when they become very old. And the trees cannot be more than 240 centimeters tall. So how can we represent the age range for these cherry trees? Okay, so they can be 240 centimeters, but they can't be more than 240 centimeters. So again, this is an inequality. I've already let the x equal the age of the cherry tree, so I'm going to go ahead and keep that. I already know that it's going to be 6 plus 9x, but this time, okay, this time it needs to be a less than or equal to, and then 240, right? So it can't be more than 240. So I'm going to go ahead, again, subtract 6 to both sides, divide by 9, so 9x is less than or equal to 234. Again, do long division if you need to, or a calculator. So x is less than or equal to 26. So the age range is it needs to be older than 16 years, but it must be younger than 26 years. So how can I represent that? Well, I'm going to put x in the middle. Always start with your largest number on this side, so it must be larger than 26. But it must be younger, must be younger than 26, but it must be older than 16. Okay, so these are just simple one-step inequalities and an example of a word problem that you might see on your homework.